Welcome to the video. My name is Pushpinder Gill. So today we are going to start the time speed distance topic. This is the first video on the time speed distance where we'll be learning the variation that happens to distance, speed and time. So this is my name, this is my email address. Do send me your valuable feedback. Let's get started. Fine. So we already know that this expression here, the distance is equal to speed into time, right? So I did not need to familiarize you guys with this specific expression. So if distance is 20 kilometers, right, and if the speed is 20 kilometer per hour, so I'm going to take 1 hour, right? So this is just an explanation of this concept here. So distance is equal to speed into time, and I want you guys to keep remember this one, right? From this you can calculate speed is equal to distance upon time. From this you can calculate that speed is equal to distance upon time, or from this you can say that time is equal to distance upon speed. Fine, right? So this is pretty basic stuff. Let's move forward. Okay, all right. So what is distance? Distance, it's what I travel. It is measured in kilometers. It is measured in miles. From this, you can also measure it in meters as well, in centimeters as well, in whatever units you want to measure in. And just for the record, you can say that 1 mile is equal to 1.6 kilometers. It's an approximation in which you can say that 1 mile is equal to 1.6 kilometers. Okay, so speed, it's measured in kilometer per hour, and it's measured either in meter per second or miles per hour. So most of the time you'll be requiring to convert the kilometer per hour into miles per second. So there's a way here. 1 kilometer is equal to 1000 meters, and 1 hour is equal to 3600 seconds. So if you already know that, then that's fine. So if we calculate it, it comes out to be 5 by 18 meter per second. That means 1 kilometer per hour is equal to 5 by 18 meter per second. So in any way you want to remember it, you can remember this way as well. Fine, right? So this is pretty basic stuff that we're doing, right? So time is measured in seconds, time is measured in hours and in minutes. So I can say that 1 hour is equal to 60 minutes. This everyone knows. And 1 minute is equal to 60 seconds. And 60 minutes would be equal to 3600 seconds, which is equal to 1 hour. So 1 hour is equal to 60 minutes, which is further equal to 3600 seconds. So this is also pretty basic stuff. Fine. So let's move forward. Now let's see the variation part. Let's understand distance is equal to speed into time. Let's understand this expression over here. Fine. Now let's suppose if I keep the speed constant. So now you guys know that distance is equal to speed into time, right? Now if I keep this constant, let's suppose this does not change, that remains constant. So if I increase my time, this distance is going to increase. If I decrease my distance, my time is going to decrease. So that means there's a direct relationship between distance and time, provided speed is constant. You getting my point? Let me take an example, right? Let me say I'm going from here, I'm going from New York to New Jersey. Fine. Right? And if I keep my speed constant, right? If my speed is constant, let's suppose I want to travel at the speed of 20 miles per hour. This is what I want to travel at. So if I travel for 1 hour, I will be traveling 20 miles, right? If I travel for 2 hours, I will be traveling 40 miles. So if I'm increasing my time, my distance is also increasing, which specified that distance is directly proportional to time, provided the speed is constant. So from here I can come up to a very good conclusion that if speed is constant, that I can say that if distance gets multiplied by k, the time will also get multiplied by k. Fine. If distance doubles, time doubles. If distance triples, time also triples. So if distance becomes n times of itself, time will also become n times of itself. Fine. So I hope it's pretty clear to you. It's very basic. The complex part comes when you have to apply this in questions. So let's see. If I travel for 50% more, then I take 1 hour more. Calculate the actual time taken to travel the distance. Now you see, in this question, speed is assumed to be constant, right? So I'm traveling at the same rate throughout the question. So speed is constant. Now let's suppose I travel d kilometers. Fine. Now he's saying if I travel 50% more, let's suppose to travel d kilometers I'm taking t hours. So if I travel 50% more, that means 50% more means 1.5 times t. If you calculate, if you watch the percentage video, you would understand that pretty easily. So if I travel 50% more, that means my distance is getting multiplied by 1.5, which is nothing but 3 by 2, right? My distance is getting multiplied by 3 by 2. That means my time over here is also going to multiply by 3 by 2, because the same number with which distance is getting multiplied, the same number the time will get multiplied with. So earlier I was taking t hours to travel the same distance. Now I'm taking 3 by 2 hours to travel this distance, and now he has told me that I take 1 hour more. That means this minus this is equal to 1 hour. That means 3 by 2 t minus t is equal to 1 hour. That means I can say that t is equal to 2 hours. From this I will be able to calculate the time taken actually is 2 hours. Right? So you see how easy we were able to solve this question, and you can solve this within your mind as well. You don't need to write all that stuff which I've written. I've just written for that so that you guys understand it. So let me just take a quick recap here. The speed was constant, right? The speed was constant and distance was increased by 50%. So distance got multiplied by 3 by 2. That means time will also get multiplied by 3 by 2. That means if I'm taking 1 hour more, that means the time taken earlier and the time taken now, there is a difference of 1 hour. That means the time taken is 2 hours. Fine. Let's move to the next point. Now the next point is if distance is constant. Now this is a tricky part. Now if I keep the distance to be constant, now let's suppose distance is said to be constant, right? I travel the same distance. Now using this expression, if you see, distance is equal to speed into time. Now if distance is constant, I just circle it. If I increase my speed, my time is going to decrease. Let's suppose I'm traveling from, again, New York to New Jersey, right? The distance is same. Let's suppose whatever the distance is. If I double my speed, my time would be halved. It's as simple as that. If you travel at the double speed, you'll take half time. So what do you conclude from that? You conclude that if distance is constant, that means that if you multiply your speed by k, your time will get multiplied by 1 by k. Just like you multiplied your speed by a factor of 2, your time got multiplied by a factor of 1 by 2. Similarly, if you multiply your t by the time by n, your speed will get multiplied by 1 by n, right? It's the other way around as well. So this is our conclusion here, that if distance is constant, speed is inversely proportional to time. You multiply speed by any number, the time will get multiplied by reciprocal of that number to just keep the distance constant, right? Let's suppose you double your speed, it gets multiplied by 2. This will half so that this and this cuts and the actual distance remains constant. Fine. So let's see what can we get from here. So if the speed of a car is multiplied by 4 by 3, then 10 minutes are saved, right? So if I increase my speed to 4 by 3 of its original speed, then I save 10 minutes. So calculate the usual time taken to cover the distance. So we know that distance is constant here, right? So let me just state that before I start solving the question. The distance is supposed to be constant. So let's suppose it takes s speed and t time to cover this distance, right? Now my speed is getting multiplied by 4 by 3. That means my speed is becoming 4 by 3s. So now if distance is constant and speed is getting 4 by 3s, so time will get multiplied by 3 by 4. right? Because speed is inversely proportional to time. So if time is getting multiplied by 3 by 4 and I'm saving 10 minutes, that means the difference between this and this is 10 minutes. So t minus 3 by 4t is equal to 10 minutes. From this I can say that the actual time taken is 40 minutes. So actual time taken to cover the distance is 40 minutes. You just solve this equation and you get your answer. So it looks very easy from here, and believe me, if you don't apply this approach, or if you try solving the question using any other technique, it's going to be very difficult for you guys, because then you'll be saying, oh, distance is equal to speed into time, plus anyhow you'll be using the same thing only, you'll be coming down with the same conclusion only, that distance is constant. So we can just use this and solve the question easily. Fine. So I hope it's understandable. So now the last part of the variation is if time is constant. So let me just write it down again, right? Distance is equal to speed into time, right? So if distance, now time is over here is kept constant. So time is constant. So again, if I increase my distance, if I want to travel more distance in the same time, that means I have to increase my speed, right? So that means I can say that distance is directly proportional to speed. Fine. So if distance is directly proportional to speed, I can come to the conclusion that if distance get multiplied by k, speed will also get multiplied by k. And if distance is divided by k, the speed will also get divided by k. Fine. It's pretty much same stuff. So if time is constant, distance is directly proportional to speed. So I hope you're understanding now, because it's becoming more and more clear, right? So let's see this question. So if I travel for 50% more, then I travel 15 miles more, calculate the actual distance. So now over here in this question, time is constant. I'm traveling for the same time, right? The distance is changing, the speed is changing, so the time is constant. So I'm traveling 50% more. Let's suppose I travel d miles and it at the speed of s miles per hour. Fine. So this is my assumption. So if I travel for 50% more, 50% more means now I will travel 3 by 2d. Then my speed would be, I'm sorry, if I travel for 50% more, then I travel for 15 miles more. I'm sorry, this is a different question. If I travel for 50% more speed, it should be like that. I'm sorry. Fine. If I travel for 50% more speed, then I travel 15 miles more. So the speed over here also would be 3 by 2s. Now you see the difference between this and this is given to you in the question is 15 miles. So I can say that 3 by 2d minus d is equal to, it's equal to 15 miles, right? Because this is what is given in the question. So from this I can say that d is equal to 30 miles. Fine. So it's a simple way and a safer way for you to solve this question. So let me just take a quick recap. So if I travel for 50% more speed, then I travel 15 miles more and calculate the actual distance, right? So if I travel d miles and now I travel 3 by 2d miles, because distance is directly proportional to speed. So that means if distance is getting multiplied by 3 by 2, speed will also get multiplied by 3 by 2. I'm sorry, if speed is getting multiplied by 3 by 2, distance will also get multiplied by 3 by 2. So the difference is already given as 15 miles. So that means actually I travel 30 miles. You can always also solve this question, right, as like I'm traveling 15 miles more and it's 50% of what I travel. So that means the 100% is 30 miles. But this approach is better. Why? Because when the complex question comes in, you would be requiring to form such equations and solving the answer. Fine. So let's move forward. Now let's see some questions over here. Now let me read this question out for you. David travels at 30 km per hour for the first 2 hours and then 40 km per hour for the next 2 hours. Calculate the ratio of the distance. Now if you see, the time is constant here, right? The time is constant. So now I have to calculate the ratio of their distance. Now if time is constant, ratio of the distance will be equal to the ratio of their speeds, which is nothing but 3 by 4. So we have our answer as 3 ratio 4. Fine. So it's pretty simple for you to solve, because the time is constant and we have to calculate the ratio of distance, which would be directly proportional to the ratio of their speeds. Fine. So this was about it. Let's see the next one. Now Maggie and John leave simultaneously from point A and point B towards each other, right? So this is point A and this is point B. So they want to travel towards each other, and they meet at point A. They meet at 40 kilometers from point A. So meet at this point. Let's suppose this is their meeting point, right? And this is 40 kilometers from here. Fine. And if the distance between 2 points is 100 kilometers, that means distance from this whole distance it's 100 kilometers. That means that the distance from this point to B is 60 kilometers. That means B has traveled 60 kilometers and A has traveled 40 kilometers. So let me write here. The distance that A has traveled is 40 kilometers and the distance that B has traveled is 60 kilometers. Right? Now remember guys, when they are meeting, actually the time taken by them to cover this 40 kilometers and this 60 kilometers is same. That means I can say that time over here is constant, right? The time over here is constant. So now he's asking the ratio of Maggie's and John's speed. Now since the time is constant and we know the ratio of their distances, the ratio of their distances is 4/6, which is nothing but 2/3, right? The ratio of their distances is 2/3. Time is constant, which means that the ratio of their speed will also be equal to 2/3, because you know that distance is directly proportional to speed when time is constant. Fine. So you didn't have to form any equations or anything like that. You will be able to solve this question pretty easily. Fine. So let me just take a quick recap. The distance between 2 points is 100 kilometers. Maggie has traveled 40 kilometers and the other person has traveled 60 kilometers. So since time is constant and distance is directly proportional to speed, that means this guy has traveled 40 kilometers, this guy has traveled 60 kilometers. So the ratio of their distances is 2/3. So the ratio of their speeds will also be 2/3. Fine. So we have to assume in this point, I'm sorry, that Maggie starts from point A, right? Okay. It should be in the question, so it's not there. So this you can start with. Fine. Let's move forward. So Nancy meets with an accident and moves at 3/4 of her speed. Due to this, she is 20 minutes late. It should be she here. Lots of problems. Due to this, she is 20 minutes late. Find the original time for the journey beyond the point of accident. So she meets with an accident and she travels at 3/4 of her original speed. Now in this, what is constant? In this, the distance is constant, right? This is what we have to find first. So distance is constant here. Let's suppose she's traveling at s speed and she takes t time to cover that distance. Now she moves at 3/4 of her original speed. That means she's moving at 3/4 of her original speed. That means the time will get multiplied by 4/3, and the difference between this time is already given to you as 20 minutes. That means 4/3t minus t is already given to you 20 minutes, right? So original time taken, if you solve this expression over here, you'll get to be 60 minutes. Fine. You see, the question became so easy for us. So let me just take a quick recap. Distance, it's supposed to be constant because she is traveling the same distance. If we assume that she takes s is the speed and t is the time, so if the speed gets multiplied by 3/4, time will get multiplied by 4/3. So the difference is given to us as 20 minutes. So if from this we calculate the original time that is taken by her is 60 minutes, and after that the time taken over here is 80 minutes. Fine. Alright, so let's see this question over here. Now I hope you're Sultan walks at 14 km/h instead of 10 km/h. He would have walked 20 kilometers more. The actual distance traveled by him is. Now if you see in this question, speed is changing from 10 to 14. The distance is changing, but time is remaining constant. So you have to look in every question which entity is remaining constant, and then you'll be able to solve your question pretty easily. So this is the old scenario and this is the new scenario. So in the old one, the speed was 10 kilometers per hour, and in the new one, the speed is 14 kilometers per hour, right? So if you see, the speed over here is getting multiplied by 14 by 10, and I am getting my new speed. That means the number by which my old speed is getting multiplied is this number, right? Which is pretty easy for you to solve. That is nothing this number but this number. So my speed is getting multiplied by 14 by 10. Time is constant. That means if I travel d kilometers now, afterwards I will be traveling 14 by 10 d kilometers. Because if the speed gets multiplied by this number and time is constant, distance will also get multiplied by this number. So that means if earlier I'm traveling d kilometers, now I will be traveling this much kilometers. So the difference between them is given to me as 20 kilometers. So that means 14d by 10 minus d is equal to 20 kilometers. And from this I can say that if I just calculate, it gives me 4d by 10 is equal to 20 kilometers, and from this I can say that earlier he was traveling 50 kilometers. Fine, it's 50 kilometers, I'm sorry. So you see, how did we, from now in the earlier questions it was given to us by what number is your speed getting multiplied by, or time is getting multiplied by, or distance is getting multiplied by. But over here we had to just go an extra step and had to calculate by which number my speed is getting multiplied. So this habit I want to create in you guys, so that you even if the question doesn't say use this method, still you're able to use that method, because you know that yes, this is what should happen in the question. So the speed was 10 earlier and the speed became 14. That means my speed got multiplied by 14 by 10. Speed gets multiplied by 14 by 10. That means distance should also get multiplied by 14 by 10, because the time is constant, right? So earlier the distance was d, now the distance is this, the difference is given to you, then you calculate the distance. Fine. Alright, now let's see this question over here. The ratio between speeds of Mary and Jerry is 7:8 while covering a distance. If Mary takes 20 minutes more than Jerry, calculate the time taken by Jerry to cover the distance. Alright, now if you see, the ratio of the speeds is given, right? And the distance, they're covering the same distance. That means distance is constant in this scenario. See, if you have observed, in every question I analyze which thing is constant. That you have to take care, because then your question's framework would be right. So distance is constant, and this ratio of their speeds, like let me call S1 by S2, is equal to 7/8. Guys, if distance is constant, the ratio of their speed is 7/8, and when distance is constant, we know that speed is inversely proportional to time. So if the ratio of the speed is 7/8, the ratio of their times would be 8/7. That would be reciprocal of that. Why? Because they are inversely proportional to each other. Now this is the speed of Mary and this is speed of Jerry, right? So this is time of Mary and this is time of Jerry. So Mary takes 8 and Jerry takes 7. So he has given that if Mary takes 20 minutes more than Jerry. So from this ratio you can say that if Mary takes 8x minutes, then Jerry would be taking 7x minutes, because it's the ratio. That's how you solve it. So from this it's given to you that 8x minus 7x, this is the time taken by Mary more than Jerry. That is equal to 20 minutes. So from this you can say, okay, x is equal to 20 minutes, and he's asking you the time taken by Jerry to cover the distance. The time taken by Jerry to cover the distance is 7x, and you know x is equal to 20. That means the time taken by Jerry to cover the distance is 140 minutes. So you see how the question became very easy. You could have calculated this question in your mind because it's so easy. The ratio of the speeds is 7:8. So the ratio of time is 8:7. Mary takes 20 minutes more. That means 8x minus 7x. That means x is equal to 20 minutes. And the time taken by Jerry is 7x. So Jerry takes 140 minutes to cover the same distance. Right? So I hope everyone understood the simple concept. Fine. So let's see one more question. Matt travels with 5/7 of his actual speed and covers 35 kilometers in 1 hour and 20 minutes. So calculate the actual speed of the Matt. So in this question, if you see, the distance is constant, right? Because he travels 5/7 of his actual speed and cover this much distance. So earlier he was traveling at his original speed and also covering this much distance. So in this question, distance is supposed to be constant. Fine. So now if he was traveling at s speed, now he would be traveling at 5/7 s speed. So earlier if he was taking t hours, now he'd be taking 7/5 t hours. Now he has given you he takes this much time, so that means this entity is equal to 1 hour 20 minutes, which is nothing but 60 plus 20, that is 80 minutes. Fine, right? So which is nothing but 80 minutes. So from this you can calculate that he was actually taking 80 into 5, that is 400/7 minutes. So this is what he was actually taking when he was traveling the same distance. Now the distance is given to you as 35 kilometers. So I can also say that the distance is 35,000 meters, because I would just want to calculate the speed in meters per second. So distance is 3500 meters, time is this much. So what is speed, guys? Speed is distance upon time. So from this I can say that speed is equal to distance, which is 3500 meters, upon time, which is 400 into 7. So I calculate my answer. It is going to come out to 35 into 7 divided by 4. So if I calculate 35 into 7 divided by 4, I get my answer to be approximately 61. Yeah, 61.25. Yeah, it is. So this is my answer, 61.25. So I hope you understood what I did over here. It was pretty easy. The distance is supposed to be constant. If I travel at the speed of s, then I'll be taking 5/7s. So if the time is t, the number with which speed is getting multiplied will reciprocate. So that means the time will become 7/5t. That would be equal to 80 minutes, because this is what has been given in the question. So I know the time, I know the distance, right? So I calculate the actual speed, because I calculated with the actual time taken by them, because that is equal to t. Fine. So I hope you understood this concept. So this was a very simple concept but very important, because most of the questions in exams like SAT, GRE, GMAT and CAT comes using this concept. So this is my email address. Don't forget me to send your valuable feedback. So now we have done the variation. We have completed the variation, and I would suggest you to practice on it, because practice will make you more than perfect. Then we will be covering a lot more videos on this, like the videos on trains, relative speed, boats and streams. So keep sticking for more videos. Thank you very much, and see you next video.